Hello everyone, welcome back to another video from Winter Forest. Today let's continue our recall question. Today's question is called a binary tree zigzag level order traverse. So basically we will receive a tree and we traverse each other. So for example, in this tree, in the root level is 3, so just 3. So each layer we are pushing into array. Then just and for the second level, in this one, put the second level the digit number into array. But instead from left to right, we from right to left. And the third level, instead from right to left, we from left to right. So if you know how to looping through a binary tree, in here then just very simple, just add one flag. We're going to do BFS. So you see this, each time we come to this level, the first level only have one item. So once we finish this one, push the child into the queue. So we need one queue. Before we unqueue it, we change a flag. By default, the zigzag is false. Since we're going to loop it once, we change to true. If the zigzag is true, we push this result to a stack, and so it array list. By default, we just appending. If you don't change, just appending to the array list. But since we need to do reverse, so we always then we push this item to the index 0 position. So basically for this one, we need one queue and one stack. The stack for our result out, and have a flag. Each time we finish one level, we change the zigzag flag. Just let's do it. By the way, just looping through binary tree kind of a pattern problem. So you need to do one or two questions looping from binary tree and push into array. I believe it just will get most of the task. And in here we expect the output, it is this one. I just copy paste in case I type in now. So this is the result we're going to read it. So in the end, I'm going to return our result is in a list of list integer. And since then root is a class, you see is a class, so class can be nullable, so we do nullable check. If it's null, we just simply return this empty linked list out. If not, we queue it. So we use a queue. We first are going to queue the root level. And then we just add the queue to add the root. So in current queue, so if we push the first level in, we have one element in. Now we also need a flag. At the moment we set it to false, start with false. Now we start a while loop this queue. If this queue is not empty, yes, this is not empty, have one element in. And inside here, this all will push into the queue. Inside here, I have a loop. First loop level by level, so I will see queue.size. First time we only looping one element, second time we loop two elements. Another time it depends how many elements in these two charts. If they have 4, then 4. If there's 2, we just 2. Okay, so now in the root pushed in, we definitely have one element. Each time we looping this one, we are pushing into array. So we need a new array list to hold this result. Now we just finish this size. And this is a shortcut. It actually will go in first, then go the second time will be 0. So if it is 1, it will do once. Okay, we just get our puller from the queue. Now queue will be empty. And we need to push new element into the queue. We always push left first. This haven't pushed the element out yet. This is just looping through the queue. So if you need a looping through the queue, find somebody, this code is definitely needed. Now we're going to push this to the. Now how we push this into our L? This level, we need a C. Push into the first element or just appending to the result. So if it is true, it means don't append to the result. I will push into the index level. Otherwise, if you just stack it, put in the last element. And for the root level, doesn't matter because the L element is empty. But when the second level coming in, so you see this one finish is finish one level. One level finish it, you get into another level. So the second time coming, it will be, and this will be true. First time this will be false. Second time will be true, so it will be each element always pointing to the first element. So the order is different. And this level, this loop, you see this size only contain the next current level size. Next time you push this chart, you have this size. Yeah. So you go into second level, third level, each one in here, and then you back to the queue until you finish the queue. So every time you come in here, it does add your result. But sometimes the L is from appending to the engine. Sometimes the L is travel backwards, like 29, and it depends. This zigzag setting. This supposed just do the job. This week's job task actually have looked at different data structure. It's very good for you understand all of this strategy, and all of the question kind of a pattern problem. So basically you could use this as a template to do a lot of similar tasks. First, we run the code, see if we can pass the, yeah, this time didn't mistyping, no syntax issue, no submit if we meet all of the scenario. Yes, it is. Thank you for watching. Bye bye.